Biodiesel, this clean, renewable fuel, is key to our energy independence and environmental stewardship. Demand for this homegrown fuel is rising. Producing quality biodiesel to meet strict industry specifications is essential.
This is really the centerpiece of trying to expand the markets for biodiesel right now.
The cold soak filtration test for B100 is vital to the fuel's purity, consistency, and performance when used in B20 blends and lower. That's why the National Biodiesel Board and the U.S. Department of Energy's National Renewable Energy Laboratory are teaming up to provide this training video to help ensure the test is conducted accurately.
The test method has to be done exactly as written, or you're going to get a different result than someone who does it exactly as written. And if everyone interprets it their own way and does it a different way, everyone's going to get a different result. And the test will be something of a random number generator instead of something we can use to set a quality specification.
Be sure to read the method in its entirety before starting the test and reference it as needed. You can get a copy at the ASTM website, astm.org. The method is expected to pass the ASTM D2 main committee ballot in June of 2008.
Well, we are trying to add this test as a requirement to the B100 quality specification, ASTM D6751, and I am optimistic that that will pass.
It'll become official once it passes and is issued by ASTM headquarters, most likely in September or October of 2008. The method will be included as a mandatory annex, meaning meeting the test limit will be required for biodiesel to be on specification. The method is only applicable to B100 and was designed so the cloud point is a valid measurement for cold filter blocking with B20 and lower blends.
The goal is to make sure that cloud point is a good indicator of low temperature operability.
Use of this method for finished B20 and lower blends has no meaning. NREL senior chemist Teresa Alleman takes us through the cold soak filtration test.
Right here we're looking at the filtration apparatus used in this method. We have two 1,000 milliliter filtration flasks, one to collect the sample and one is a guard flask. We have a filter holder available from a scientific supply company. This filter holder is capable of holding the entire sample or 300 milliliters of liquid. We have a stainless steel filter support, which is the only support approved for use in this method. Glass, fritz, or other materials are not approved. The vacuum pump here is attached to a gauge to measure the pressure. The pump must be capable of sustaining 21 to 25 inches of mercury for the duration of the test. The apparatus should be grounded. Use clean tweezers to handle the filters during the method. Be sure not to rip or tear the filter when handling. If this happens, discard the torn filter and use a new one. The filters are stored in petri dishes, supported on watch glasses, to ensure no particulate is picked up prior to filtration. In most cases, the thermal memory of the fuels used in this method will need to be removed. See the method for specifics. In order to accomplish this, an oven capable of heating the fuel to 40 degrees Celsius is needed. The cold soak is performed in a liquid or air bath held at 4.4 degrees Celsius. If a biodiesel sample has been collected from a heated tank at a production facility, collect a 300 milliliter sample in a 500 milliliter bottle. Glass bottles are preferred for this method to allow visual inspection of the sample during the method. Make sure the cap has an inert liner. If the biodiesel has been shipped to a lab for analysis or has cooled to below 20 degrees Celsius during transport or storage, the thermal memory of the fuel must be erased. This is my associate Lisa Fouts, who will be demonstrating the method for us. To begin removing the thermal memory from a fuel, Lisa will shake the fuel for 1 minute. After shaking, transfer 300 milliliters of fuel to a suitable 500 milliliter container. Before capping the sample, purge the headspace with an inert gas, such as dry nitrogen, and seal. Heat the fuel in a 40 degrees Celsius oven for at least 3 hours. After heating the fuel, remove from the oven and let set at room temperature. Note the temperature during this period must be at least 20 degrees Celsius. Prepare the water or air bath so the bath or chamber is at 4.4 degrees Celsius. When the bath has reached 4.4 degrees Celsius, put the fuels in the bath. NREL is using an environmental chamber, but a liquid bath is also suitable. Notice how the fuels are put in the chamber with lots of room around each bottle. The time-lapse camera will show the impact of the time and temperature on the two fuels, one with the cloud point above 4.4 degrees Celsius and one with the cloud point below 4.4 degrees Celsius. After the 16-hour cold soak period, gently remove the fuels from the air or water bath. The fuels are removed with a minimum of agitation and shaking. The fuels are placed on the lab bench top and the temperatures are monitored. The temperature can be monitored with a thermometer or a thermocouple readout as shown here. The temperature is monitored at the middle of the fuel. No external heat or shaking is permitted in this method. Once the fuels reach room temperature, defined in the method as 20 to 22 degrees Celsius, the filtration must be performed within 1 hour. The filter should be baked at 90 degrees Celsius plus or minus 5 degrees Celsius for 30 minutes, then cooled to room temperature prior to using. Note how the filters are handled carefully with tweezers to minimize contamination and tearing. The filters are supported by a watch glass in a petri dish. When all the filters for the day's run are laid out in individual petri dishes, they are carefully put into the oven. The covers of the petri dishes are left slightly ajar during the heating process. After 30 minutes, carefully remove the petri dishes and place them on the lab bench at an ambient temperature no less than 20 degrees Celsius. The covers are again left ajar for the cooling process. After the filters have cooled to room temperature, begin the apparatus assembly. Note how Lisa has secured the filtration flasks with hose clamps to ensure a tight fit. She will then place the bottom of the filter holder in the receiving flask. Lisa is laying the gasket in the groove with it in the up position. She will then carefully lay the stainless steel screen on top of the gasket. After laying the stainless steel support screen in the filter holder, she will carefully, using tweezers, place the filter on top of the support screen. She will then complete the assembly of the filter apparatus by placing the top portion on the filter and clamping it with the metal clamp. This clamp will be grounded. After that, Lisa will cover the apparatus with some parafilm to prevent contamination prior to the filtration. After the fuels have reached room temperature, remove the cover from the filtration apparatus. Gently swirl the first fuel for 2 to 3 seconds. If the fuels have been chilled in a water bath, wipe the area around the cap of the fuel prior to filtration to minimize contamination from water. Start the vacuum pump. Start the timer at the same instant you pour the entire contents of the fuel sample into the filtration apparatus. After 1 minute, record the vacuum. If the vacuum is not between 21 and 25 inches of mercury, make adjustments to the vacuum system. After 720 seconds, or all of the fuel has been filtered, stop the timer. Record this time. Dispose of the fuel and the used filter paper in a method appropriate for your organization.
Follow these exact steps for the cold soak filtration test for precise results and optimal fuel performance.
We found that some biodiesel can contain impurities that cause problems in the wintertime. And this test is critical for ensuring that biodiesel that contains these impurities isn't used and doesn't cause problems.
As always, take all proper precautions to address the health and safety issues associated with the method. This method is being balloted as a mandatory annex to D6751. At ASTM, Subcommittee 14 is working to further develop and refine the method. Once the method is completed, it'll be balloted into D6751 to replace this mandatory annex. The NBB and NREL will keep you informed as we continue to advance this technology.
I just measured out the 300 mils.
I think it's very exciting to be doing something that's going to lead to pretty significant reductions in imported petroleum and potentially greenhouse gas emissions.
A precise cold soak filtration test. It's crucial to producing quality, reliable biodiesel that's better for our economy and our climate.